Somewhere in China right now, engineers are pulling fuel out of thin air, not from underground reserves, but from carbon dioxide, water, and sunlight. The same nation has just converted frozen air into a power source capable of lighting a city for 10 consecutive hours. It is producing rocket-grade chemical compounds using nothing more than sunlight and seawater. And it has recently set a new record in its pursuit of controlled nuclear fusion, a technology that could theoretically supply the entire planet with power indefinitely. 6 distinct innovations unfolding simultaneously, all converging toward a single ambition that most people have never even heard of. By the time you finish reading this, you'll understand exactly what that ambition is and why it may reshape the global balance of energy power for the next century. To understand why these breakthroughs matter, it helps to start with the vulnerability that inspired them. China manufactures more goods than almost any other nation on Earth. Electronics, vehicles, machinery, consumer products of every kind. Its factories operate around the clock, and its urban centers have expanded faster than almost anywhere in modern history. Nearly any manufactured item, examined closely enough, traces some part of its origin back to a Chinese production line.
All of that industrial output depends entirely on energy. And the overwhelming majority of that energy still comes from oil.
More than 70% of the petroleum China consumes is imported from other regions. The Middle East, Africa, and Russia among them. That dependency alone would be a significant vulnerability.
But the deeper issue lies in transportation.
Nearly every barrel must cross the ocean by tanker.
And almost all of those tankers pass through a single narrow channel, separating Malaysia and Indonesia, known as the Strait of Malacca. Picture a funnel. On one end, the vast expanse of the Indian Ocean, carrying tankers from the Middle East and Africa. On the other, a passage barely 3 kilometers wide at its narrowest point, forcing ships to move through in careful, slow sequence. Roughly 1 in every 4 barrels of oil traded globally passes through this single corridor.
Roughly 1 in every 4 barrels of oil traded globally passes through this single corridor. Should that route ever be disrupted, even briefly, the ripple effects would be immediate.
Factories could stall, prices could spike overnight.
And the shock would extend well beyond China's borders. Given how deeply global supply chains are intertwined with Chinese manufacturing,
they call it the Malacca dilemma.
it isn't a new concern. China has spent years attempting to mitigate it.
Through overland pipelines across Central Asia and deep-water ports in Pakistan and Myanmar.
And vast underground reserves capable of sustaining months of emergency supply. Yet none of these measures eliminate the fundamental problem.
The oil still has to reach Asia by sea before any of those alternatives can function.
A stockpile merely delays the inevitable depletion. This underlying vulnerability is precisely what these 6 breakthroughs were designed to dismantle.
The guiding question became,
What if fuel didn't need to travel at all? What if it could be manufactured on-site, from materials available almost anywhere? That question gave rise to the first major innovation: fuel synthesized directly from air. Using sunlight, water, and atmospheric air to generate usable energy. Except instead of feeding a plant, it produces pure jet fuel. A facility in China is doing precisely this right now. And the underlying chemistry turns out to be surprisingly straightforward. The process begins by capturing carbon dioxide directly from the atmosphere, separating it into pure hydrogen and oxygen. The carbon dioxide is combined with the hydrogen under controlled, extreme heat and pressure, producing a liquid fuel that is molecularly identical to conventional jet fuel. An aircraft engine cannot distinguish between the two. Only its point of origin differs. The company behind this technology launched its facility in January 2026. Located deep in Shanghai's highly advanced Lingang district. Current output remains modest, roughly 100 tons annually. But plans call for rapid, massive expansion. A demonstration facility, followed by a stage targeting 100,000 tons annually by 2027. Synthetic fuel solves one puzzle. But what happens when renewable generation drops off after sunset? Even the most advanced battery installations typically provide only a few hours of backup. To address this, engineers in the vast Gobi Desert developed a highly unconventional system. A system based entirely on liquefying ordinary air. Air cooled to roughly negative 194 degrees Celsius. It transitions into liquid form and can be safely stored in massive tanks. When energy is needed, the liquid is allowed to warm and rapidly expand. Expanding to hundreds of times its volume to drive massive power turbines. This facility operates seamlessly alongside a massive solar installation. Notably, the process requires absolutely none of the rare materials like lithium or cobalt. While this addresses the power grid, shipping and heavy industry require a combustible fuel. The solution comes from an unexpected source: green ammonia. Ammonia's incredible relevance lies in its capacity to carry hydrogen efficiently. Hydrogen itself is exceptionally clean, producing only pure water vapor when burned. But it is notoriously difficult to transport due to its incredibly low density. Ammonia solves this by binding hydrogen molecules into a stable, easily shippable liquid. A facility in Shanxi province has demonstrated an alternative approach to creating it, producing it from atmospheric nitrogen and solar-derived hydrogen at room temperature. Ammonia-powered cargo vessels are already being tested on active global shipping routes. A broad shift toward ammonia would render oil-based shipping fuel completely optional. Each of these innovations ultimately traces back to a single common ingredient: hydrogen. It is the core thread connecting every single technology discussed. a nation's capacity to produce it may prove more strategically significant than its oil reserves. China's clean hydrogen output has seen a massive, nearly six-fold increase in just 5 years. Guangdong province alone is constructing a massive offshore wind facility, built specifically to power extreme water-splitting equipment. China also manufactures approximately 65% of the world's electrolyzers, giving it absolute, undeniable influence over the pace of hydrogen adoption globally. Even established, century-old oil interests are being forced to adapt rapidly, converting existing fuel facilities into advanced synthetic jet fuel plants. But one final piece completes this puzzle, as solar and wind still depend on variable weather. The one technology capable of providing truly constant, limitless power. Nuclear fusion, the exact same process that powers the sun itself. Forcing atomic nuclei together under extreme heat, releasing enormous, endless energy. Using hydrogen derived from water, so abundant that a single lake could sustain a reactor for centuries. China's flagship fusion device recently achieved a massive new record for plasma confinement. The true significance of fusion lies in how it would endlessly amplify every other breakthrough, creating an energy system built entirely on a closed loop, completely independent of geography, and controlling the geographic choke points where that oil was forced to travel. But if energy can be manufactured anywhere, that traditional source of leverage completely erodes. Influence shifts permanently to those who manufacture the equipment.
China currently leads this manufacturing capacity by a massive, staggering margin,
effectively exporting the infrastructure of this emerging era, just as nations once exported crude oil. Renewable fuel capacity is expanding, and refineries are being reconfigured today. These are not mere conceptual projects. They are massive, active construction sites. It is quietly, inevitably losing ground to alternatives that are faster, cleaner, and unstoppable. One facility, one technology, and one nation building the future, piece by piece. Even as much of the world continues debating whether this massive shift is genuinely underway,